After looking at the graphs for all of our trig inverse functions, let's kind of summarize a few important trig inverse information topics. Number one, it's a notation thing. Sine inverse of x is the same thing as arc sine of x. So you're going to see both of these in your textbook. So cosine inverse of x is the same thing as arc cosine of x. Tangent of x, or excuse me, tan inverse of x is the same thing as arc tangent of x. Okay, so that's just a notation thing. Next up, on the unit circle, sine inverse of x and tangent inverse of x exist just in quadrants 1 and 4. And the reason for that is we know that the range of both of these exist from negative pi over 2 to positive pi over 2. So on your unit circle, we know that positive pi over 2 is up here, and negative pi over 2 is actually the same thing as, 3 pi over 2. Okay, so sine inverse and tangent inverse only exist in the first and fourth quadrants. Now, all of the angle measures in these two quadrants are going to be written as, the first quadrant's going to be normal, so this will still be pi over 4. But down here, instead of saying that it's 7 pi over 4, it's going to be negative pi over 4 because all of the values have to exist within this interval. Okay? So this is pi over 6. This is now going to be negative pi over 6. This is pi over 3. This is negative pi over 3. Okay? So all the angle measures in the first quadrant stay the same, and then in the fourth quadrant we just do the opposite of them. That's for sine inverse and tangent inverse. For cosine inverse, it only exists in quadrants 1 and 2. Again, that's based on the fact that the range for cosine inverse is from 0 to pi. And on the unit circle, here's 0, here's pi, so it's just in the first and second quadrants. And all angle measures are just what they normally are there. You don't have to worry about doing the opposite of anything. All right? And the last and pretty important thing is that there's only going to be one answer for inverse functions. Okay, so when you evaluate a trig function, say I ask you for sine of pi over 3. Well, we know that that answer is the square root of 3 over 2. Okay. So when you're evaluating a trig function, what you're given is the angle measure, and what you're looking for is an ordered pair number. Okay, since it was sine, we took the y value of the ordered pair. Now, when you're evaluating an inverse trig function, so for example, say I ask you to find sine inverse of 1/2. Now this time, what you've been given is the ordered pair number, so what you are looking for is the angle measure. So this is like saying, what angle measure corresponds to sine equaling 1/2? And because we spent so much time with the unit circle, we know that that answer is pi over 6. Okay. So anytime you're evaluating an inverse trig function, your answer is going to be a radian measure. All right, so big ideas. Sine inverse of x equals theta. So your answer is going to be an angle measure in radians. Whatever you're taking sine inverse of has to exist between -1 and 2, because that's the domain for sine inverse. Your answer, that angle measure, has to exist between negative pi over 2 and positive pi over 2. So you can only look for your answer to sine inverse in quadrants 1 or 4. If it's cosine inverse of x, all right, so again, your answer is going to be an angle measure in radians. Whatever you're taking cosine inverse of, it has to exist between -1 and +1. And your answer has to exist between 0 and pi. So your answer, that angle measure, will be found in either quadrant 1 or quadrant 2. And then for tan inverse of x, whatever you're taking tan inverse of, it can be any real number because that's what the domain was for our tan inverse function. Your answer has to lie between negative pi over 2 and pi over 2, but it cannot equal either of those because that's where the horizontal asymptotes happened on our graph. So just like with sine inverse, you're looking in quadrants 1 or quadrant 4. So let's take all that information and look at a couple examples. So say you're asked to find cosine inverse of 0. Well, first of all, does 0 exist between -1 and +1? Yes, it does, so we know that we'll have an answer here. Since it's cosine inverse, we are looking in the first and second quadrants. So where is cosine equal 0? Well, we know it happens up here because of that ordered pair, 0, 1, so that happens at pi over 2. So that's our answer. Cosine inverse of 0 equals pi over 2. Now, a couple more examples here. Ooh, there we go. So if we want to find arc sine of -1/2, is -1/2 exists between -1 and 1? Yes. So then we'll go and we'll look in the first and fourth quadrant. Now, since it's -1/2, we know that it's going to be down here. Okay, so it's going to exist in the fourth quadrant. We're basing it on sine, so we want to know, okay, where is our y value? -1/2. So that's like saying the square root of 3 over 2, -1/2. So we know that that happens at pi over 6, and since it's in the fourth quadrant, it'll be negative. So our answer here is negative pi over 6. All right, on example 3, sine inverse of 1. Does 1 exist between -1 and 1? Yes, it does. All right, so then we go to our first and fourth. Since it's positive, we'll just focus on our first quadrant. All right, so where is the sine 1? Okay, so where's the y value 1? That happens at 0, 1, and we know that that's going to be at pi over 2. So our answer here, pi over 2. All right, cosine inverse of negative square root of 2 over 2. Well, first of all, does this exist between -1 and 1? Yes, it does, so we know we can find an answer here. Since it's cosine inverse, we focus on our first and our second quadrants. Since it's negative, I think all students take calculus, so which of these is cosine negative in? This one, so we'll be focusing over here. And since it's square root of 2 over 2, we know that that's a multiple of pi over 4. So if this is 1 pi over 4, this is 3 pi over 4, and that's your answer. All right, now for arc tangent of 1. Is 1 a real number? Clearly. So we go to looking in our first and our fourth quadrant because it's a tan inverse or arctan. Since it's +1, we'll focus specifically in the first quadrant, and tangent is 1 at pi over 4. So there's our answer. Arctangent of 1 equals pi over 4. All right, now down here, if you're asked to find sine inverse of 2, does 2 exist between -1 and +1? Well, no, it doesn't, so there's no solution there. This is also why on the very first day when we started doing this, when you were asked to find sine inverse of 45 degrees, that's why we got a no solution, because 45 clearly is not between -1 and +1. Right. Now, down here, if we have arc cosine of 5 pi over 4, well, if we do 5 pi divided by 4, that's 3.92. Clearly, that's not between -1 and 1, so this would also be a no solution. Now, based on those examples, this is your homework assignment.